So we can combine multiple resistors. So there's two main types of connections we have, which are series and parallel. So in series, basically the resistors are going to be connected one by one, so all in a row like that. Whereas in parallel, they're going to be connected, all of the legs of the resistor are going to connect to the same points. If that makes any sense. So in the series, we basically still have one pipe that carries all of the current. You have more blockages, more resistances in the total pipe, but same pipe, same amount of water going through all of that. Parallel, we have that your big water supply, your voltage, but then you come up to that part where it splits off into multiple paths. So in parallel circuits, the current over the resistors will split off into different paths, basically. They'll rejoin at the end at that other end where they all meet back up again. So basically, continue with series circuits. It's all one wire, all one connection, no splits or junctions. So current is going to be the same through all of the units. So if we know that I is going to be same through all of the units and we have varying R, then if we measure the voltage of each individual resistor, they're going to be different. So each resistor is going to absorb a different amount of energy, basically. So the higher resistance, the more energy it's capable of absorbing. Okay. And what we can do is if we have multiple resistors, let's say, and we want to find what the total resistance of the system is, say, because you don't want to buy 10 resistors, you just want to buy one to substitute your circuit. So you can find your equivalent resistance just by adding all of your resistors, the resistance values together, and that's going to be the total resistance of the circuit. Make sense? Parallel is a little different. So I already explained that voltage is kind of a relative difference between 2 points. So as you guys kind of saw in the parallel circuit, all of the resistors all of the resistors were all connected at the top and at the bottom. So these are all connected at this one point by wires. We don't consider wires to be anything that interferes with this. So they're all connected at the same point. And voltage is relative, so it doesn't matter what path you take, it's just a difference between 2 points. So in parallel, all of the units are going to have the same exact voltage. But because they could have varying resistances, you're going to know that the current will be different through each. That's what we're saying with the water analogy. The current is going to split through the different pathways it has and rejoin at the very end. So this is kind of different where versus series parallel circuits, the lower resistance, the higher current is going to have. So say this is going to be like 3 pipes. One has a really high resistance, so it really doesn't want anything to go through. One has basically no resistance. So more water is going to be able to flow through the one that doesn't have any resistance versus the one that's blocking most of it. So the equivalent resistance for this is a little more complicated. It's kind of an inverse relationship. The formula is 1 over the equivalent resistance equals 1 over, kind of got messed up on this. I'll rewrite it here. All of you. So 1 over the equivalent resistance equals 1 over R1 plus 1 over R2, and so on. Are y'all good on that?